Calculus 1 Final Exam Review, Problem 1. G of negative 2 is the y-coordinate associated with x equals negative 2. We see at x equals negative 2 this vertical asymptote, which means that this function is not defined at negative 2. Our answer then is g of negative 2 is undefined. Since part 2 involves a two-sided limit, let's do part 3 first, which is a one-sided limit. As x approaches negative 2 from the left, look at the graph just to the left of where x is negative 2 and getting closer to where x is negative 2. So our view is like this, and we see that this function's y values are decreasing without bound. So we say that this one-sided limit is equal to negative infinity. Now if there is an infinite limit, that does not mean the limit exists, but that infinite limit tells you the manner in which the limit does not exist. By being infinite in this case, negative infinity. Now moving back to part 2, this is a two-sided limit, which means we have to look at the limit as x approaches negative 2 from the left, versus the limit as x approaches negative 2 from the right. We just got done saying in part 3 that the limit from the left is equal to negative infinity. Now let's look at the limit as x approaches negative 2 from the right. So we are just to the right of negative 2 and getting closer to where x is negative 2, so our approach is like this. And we see that this graph increases without bound, which means that this one-sided limit is equal to positive infinity. That one-sided limit does not exist because it's infinite. The manner in which the limit fails to exist is because it's infinite. Finally, because these two one-sided limits disagree, we say that this two-sided limit does not exist. That's the answer to part 2. Let's look at part 4. G of 0 is the y-coordinate associated with x equals 0. This empty hole here means this is not included. This is an excluded point. But right up here, this is the point whose x-coordinate is 0 and whose y-coordinate is 4. G of 0 is that y-coordinate 4. We write G of 0 equals 4. In part 5, we have a two-sided limit. We must look at the limit as x approaches 0 from the left, and we must look at the limit as x approaches 0 from the right. The question is, do these one-sided limit values agree? As x approaches 0 from the left, we are on this portion of the graph just to the left where x equals 0 and getting closer to where x is 0. Reading the y-coordinates along this one-sided path, the y-coordinates are getting close to 1/2. As we approach 0 from the right, we are looking at this portion of the graph, and the y-coordinates along this one-sided path are getting close to the value 4. Because these one-sided path limits do not agree, we say that the limit as x goes to 0 of g of x does not exist. In part 6, we have g of 2. This is the y-coordinate associated with x equals 2. Here's where we are looking. That empty hole means there is no point on the graph whose x-coordinate is 2. Therefore we say g of 2 is undefined. Now although g of 2 is undefined, the limit as x goes to 2 of g of x, which we will look at in part 7, may exist. In fact, we'll see that it does in a moment. The limit as x approaches 2 from the left takes us to this portion of the graph, looking in this direction, analyzing the y-coordinates. And the y-coordinates of these points appear to be getting closer and closer to 1/2. The limit as x approaches 2 from the right takes us along this portion of the graph to the right of where x is 2, and getting closer to where x is 2, we analyze the y-coordinates. Y-coordinates of these points appear to be getting closer and closer to 1/2. Since these one-sided path limits agree, this general two-sided limit exists and the value of it is 1/2. G of 4 is the y-coordinate associated with x equals 4. So we look right here, that point has x-coordinate 4 and y-coordinate 2. Therefore, G of 4 is that y-coordinate 2. G of 4 equals 2. In part 9, we are looking at the general two-sided limit, the limit as x approaches 4 of g of x. We must compare the limit from the left versus the limit from the right. As x approaches 4 from the left of 4, we're looking at this portion of the graph. The y-coordinates, it seems clear they are increasing without bound. This one-sided limit is equal to positive infinity. Similarly, from the right, we are looking at this portion of the graph. The y-coordinates are increasing without bound. The limit from the right is positive infinity. Now, since these one-sided path limits agree, we can write the limit as x approaches 4 of g of x equals positive infinity because of that agreement. Still, the limit does not exist because it's not a finite number. Finally, looking at part 10, the limit as x approaches negative infinity of g of x. It's a little bit hard to tell because the graph is not very precise. But let's assume that the graph looks like this as we extend infinitely far leftwards. And let's assume that we can see more of the x-axis to the left. As x approaches negative infinity, our perspective is to move infinitely far leftwards and analyze the y-coordinates. It looks like the y-coordinates are getting closer and closer to 0. Therefore, we write that this limit is equal to 0.